A lot of people use solvents. For those of you that are younger than I am, which is pretty much everybody, solvent, there used to be, anybody know what vapor degreasing is? Okay, the young guys at the end. Vapor degreasing, they would take real reactive solvents and they would put it in a bowl and heat it. They'd have a dome over it, so the solvents would come up as a vapor. They would condense on the dome and then they'd fall down over the parts. And it was a real good cleaner degreaser, and it worked really well to get grease out of threads in machine shops and whatnot. The problem with that is all the good solvents, all the real aggressive solvents are now illegal. They're either illegal or they're so highly regulated they might be illegal. So what was once a good technique, which is solvent degreasing, they're trying to do it now with acetone, or they're trying to do it with rubbing alcohol and isopropyl or whatever. The problem with that is when you try and do it with a solvent, what you're actually doing is just diluting the grease or the substance on it. So we'll show you some pictures. We'll run across some pictures later. We did a test on the wiping, but if you can get them, they need something that actually saponifies the oil and grease. And saponify means turn into soap. So what happens, a caustic-based cleaner or a detergent actually attacks the oils and greases and traps them. If you use a commercial product like Easy Off or Dawn detergent or something, it also has a rinse agent. So sodium hydroxide, pure sodium hydroxide or lye works really well, but it's very, very hard to rinse. So anybody ever get lye or sodium hydroxide on your fingers? No? If you're a chemist, you get it on your fingers and it starts turning your fingers to grease, and it's real hard to rinse off because it keeps turning your fingers to grease. So, but a detergent, we like a strong caustic solution. As I said, for testing purposes, we like Easy Off Oven Cleaner. Because easy, simple, you spray it on, you let it sit a minute, you rinse it off. If a guy says your braze alloy won't wet or his parts won't wet, see if you can get him to hit it with an oven cleaner. And I got to tell you, on this cleaning, routinely the answer I get is, yeah, my parts are clean enough. Okay, yeah, we know how to clean parts. And I had one last week where a guy called, he was welding little carbide like pencil leads onto bandsaws for carbide tip bandsaws. And we started running through the list and where are you getting the carbide and how's it being treated and whatnot. We got to the end, then he told me that they had two lines running side by side and all the problems were coming off of one line and not the other, which eliminated a lot of my first guesses. But he said they hadn't checked the cleaning tanks in a long time, and a lot of times they will charge a cleaning tank and then they'll let it sit and let it sit and let it sit. And if it degrades enough, or even worse, if they run some particularly bad coated steel through there or whatever, they can get an oil film on it. So you run it through the caustic cleaner, get it clean, then you pull it out through an oil film and put oil back on it. We've seen people that when they get through grinding saw tips or saw plate, with a saw plate it's got a notch to put the carbide in it. What they'll do is they'll grind that notch out, then we'd really like to have them wipe it with a clean towel. A lot of times they'll wipe it with WD-40 because WD-40 is good. And if they wipe it with WD-40, what they're doing is recontaminating the joint. Down here we had, this is what I meant about the difference between welding and brazing. This is a welding approach. This is carbide in a notch. Okay, that's a piece of carbide and a piece of steel. We've made some real good friends who bought from us and from you for a while until the next guy came along with a miracle substance. And if you're not running into it, by the way, every year or two somebody comes along with a miracle alloy or a miracle flux and just screws up everything, because typically the customer will call you because you answer the phone and he'll say, I'm having brazing problems. And you say, did you change anything? And he'll say, no. Okay? And then you start asking him the questions, you get down, what flux are you using? and they'll say, well, this guy came along and sold us a flux that was better than what you were selling us, but that can't be it because he said his flux was better. Okay? And you guys know the difference between white flux and black flux? Okay. For those of you that didn't nod, white flux is potassium salts of boron and fluorine. Black flux is white flux with extra boron in it. Okay? We have found the British, in my industry, the saw and tool industry, some people like the white flux better because they can see the work. We recommend the black flux because it's more forgiving. We have solved a lot of brazing problems by having them switch from a white flux to a black flux. And what we think happens with the black flux is that the extra boron that's added serves as an extra cleaner, but we're not sure. Also with flux has, if they ask about flux and does it have cleaning properties, our answer is yes, but don't count on it. We tell people that flux is to be used as an oxygen interceptor and to a lesser extent to protect the work area. So they need to start with a clean plate, free of oxides, free of oils and greases, and then put on lots of black flux, use it. And it does serve to protect the heat. It also, in certain cases, as with us in saw plate, they will flux quite a ways back from the joint to prevent coloration on the steel. So we think flux is cheap. Certainly it's cheaper than the problems you get if you don't use enough of it. But anyway, in this case, welders will try and braze carbide in a notch this way. They will heat it up and they will try and get the braze alloy to wick in because that's what you do welding. We recommend you take wire bits and put them down underneath. And this works pretty well because when the wire bits melt, the part settles and you know you've got enough heat in the joint. Brazing carbide for the first time, they really want a reducing flame. You want something. You don't want an oxidizing flame or a neutral flame. You want a reducing flame. Here's what we use, and if you can get them to do it, these are mild steel bars, 6-inch longs, 1/2 inch wide by 1/8 of an inch. We take them, run them through a bench grinder. We just bench grind one end, and then to test, we'll put a little bit of braze alloy and some flux. These have been pretty badly overheated, but it wets out nicely. Then we'll take them and put a pair of pliers on and see what happens. Try and twist them off with pliers. We also will clamp them in a vise. This is what happens. This is indicative of a bad surface treatment on carbide. When tungsten carbide is made, they take tungsten powders, carbon powders, cobalt powders, and wax. And what they do is they mix them together, and then they press them to form them, and then they melt the wax out. And then what you have is the 3 constituents, and then they center them under heat and pressure. What that does is relax the tungsten lattice. The carbon goes inside the tungsten lattice. That forms tungsten carbide grains, which are held together by cobalt, typically cobalt. So it's like concrete. You've got the tungsten carbide grains held together with cobalt. If you don't use enough carbon, you get weak places in the tungsten carbide. That's called etaphase or etaphase. If you get weak places, you've got a bad piece of carbide. If you use too much carbon, then what you get is the extra carbon deposits on the surface, which is real good for the carbide people, but you can't braze to, it's like trying to braze to graphite.